3 of the mechanical energy equation, and this is a very critical, important point, is setting the initial point, which is A, and setting B, which is the final point. So this is definitely important on what are you asked or what do you need to calculate, or even how to simplify it. For example, in this system, if I were to tell you the pressure on this point right here, because I'm studying this, I'm the engineer of this equipment right here, and I just know that the pressure cannot be larger than, I don't know, 3 atmospheres. You have more than 3 atmospheres, this will explode and will destroy the plant. But there's also the engineer, which is the fluid engineer, and wants to move this fluid A to fluid B. But this B is not your B. Your B is right here. So you just need to know and understand that you can do the balance whatever you want. You can do it A and B. You could do it A and B in this valve. For example, let's say this fitting right here has a, let's say, a maximum pressure, and if you use extra pressure, well, you're going to have leakage, small leakage, or even it may be destroyed. So you want to calculate the maximum pressure, and so on. You can do whatever points you want. If you don't know the level of this tank, well, you can avoid, I don't know, maybe getting the data from this point right here. Maybe this is not accessible. Maybe it's a petroleum reservoir and you cannot access it, but you could, I don't know, go get a manometric apparatus equipment here. You can calculate the velocity with an equipment, and you know the height of your plant with respect of this piping, and you are done. So what I want to tell you guys is that you can choose A and B in whatever place you want. You need only to know what do you want to calculate and how to simplify it. So for example, if I wanted this point right here, you could simplify it and say, well, since we are working in atmospheric pressure, we have no difference on pressures. Or maybe you want to do a straight pipe. Well, actually, let me continue that in another video. The important part right here, guys, is once again, be sure on what balance do you do. For example, you have this pump right here. There is a very important topic in pumping, which is cavitation, and is the minimum pressure you need at the suction in order for the fluid to maintain its liquid form. If it goes gas or vaporizes, it will destroy the pump and it will be a catastrophe. This was a free preview. You want to get full access, go to my incompressible flow course. The link is in the description of the video. You will get all access. Not only that, you get a very straightforward, user-friendly interface. So for instance, you were analyzing or studying pumps, you have it here, the pump block, and then you have the sections. If you were, for example, studying the types of pumps, you can go here, and you have all the classes right here. Not to mention that you also have introduction and conclusion of every one of these. So for instance, if you were studying positive displacement pumps, the video is right here. If you were studying positive displacement pumps in rotatory and reciprocal are also included here. Centrifugal pumps, which is a very important topic in this course, you have it right here.